Hello, my name's Mark Saunders and this is a YouTube video presentation on the paired t-test. This is also known as the dependent t-test or the repeated measures t-test, and it's used for testing statistically whether two related groups are different. We're going to start by an overview of what we're going to do in this video presentation. We're going to be looking at, first of all, at hypothesis testing and testing for statistical significance. And within that, we're going to talk a little bit about testing for differences between two related groups before we move on to looking at the paired t-test. Remembering that the paired t-test is also known as the dependent t-test and the repeated measures t-test. We'll start by looking at the components of the t-test. Then we're going to look at what the data looks like in a data matrix, which we might put into Excel or SPSS. We're going to consider the assumptions of the test, hypothesis and hypothesis testing, and how to report the findings. And we'll finish with further reading. Let's look at what we mean by hypothesis testing using the paired t-test. For hypothesis testing using the paired t-test, we're assessing the statistical difference of data from a sample, and we're looking here for the difference between two related things, be they times, so a before and after, conditions, what happens if we do something, and we're looking at groups which have been matched as pairs. The hypothesis is our tentative explanation of the difference. So our hypothesis might be there is a difference in whatever it is between the two related groups. We would express this perhaps as there is a difference in employees' sales before and after a customer service training course. So here we would be looking at the implications or the impact of the employees going on a training course. A null hypothesis would state there is no difference between the two related groups. So in this particular example, there is no difference in employee sales before and after taking the customer training course. So when we're testing for differences using the paired t-test, we have a number of requirements. The first is that our data must be numerical, and these measurements represent two different times, before and after, two different conditions, and the groups must be related as matched pairs, and we'll see what that looks like in our data set. The subjects in our groups are the same, so for each case we have a before and an after measurement, and these are paired measurements and they're recorded in two separate variables. Our paired t-test analyses the variance, that's the spread of data values within and between the two related matched pairs groups. So if you look in the diagram, we have group 1 and group 2, and we look at the within group variation and between the group variation. And what we're seeing is whether the variation is greater within the groups or between groups 1 and groups 2. So we're looking at the before and after measures and seeing are they statistically significant. In other words, we're looking at the likelihood of a difference between the paired times, conditions or groups occurring by chance. And if there is a low likelihood, normally a probability of less than 0.05, which is 1 in 20, we usually consider this difference to be statistically significant. The components of the paired t-test are the test statistic, which we know as T, degrees of freedom, which we know as degree DF, and based on these we can calculate a statistical significance or P level. Where the probability of the test statistic value, or one more extreme, occurs at less than the prescribed significance level, normally P is less than 0.05 or 1 in 20, this provides evidence against our null hypothesis. The data we have are therefore compatible with the explanation expressed in our hypothesis, and for our example, there is a significant difference in employee sales before and after the customer service training course. Our data comes as a data matrix where each row represents a separate case and each of the columns represents data collected about that particular case. In the case of the paired t-test, We have an identifier, as always. This allows us to get back from our data matrix to the data. And we have two variables representing, in the case of our example, sales before the customer service course was taken by the individual case, so person 1, and sales after. In this case, exactly 6 months after. So for person 1, they had sales value of 34,321 before the customer services course, and after they'd taken the customer services course 6 months later, to allow for time for things to settle down and learning to be embedded, they had sales of 45,672 in value. The data values for each variable are recorded across the cases. So we can see here case 1, case 2, case 3, and also case 4. And they're related specifically to these individual cases. When we look at case 4, we can see that values have only been recorded for one of the two variables, and that means we need to exclude these data from our analysis because we don't have data for both variables. In other words, the pair of data values which we're going to be testing. These data are normally analysed using software such as Excel or SPSS. If we're going to use a paired t-test, we have to satisfy a number of assumptions. The first is that our numerical data for each of the two paired variables must be normally distributed. And Hayes tells us that this assumption is not particularly important, provided the number of cases in each group is large, 100 or more. Fortunately, for our data set, the data are numerical and they're normally data distributed. The second assumption we need to satisfy is that the numerical data for these two variables do not contain any outliers. These are values which are much larger or much smaller than the general values we've got in our pairs of data. And again, fortunately, the two paired variables numerical data do not contain any outliers. Because of this, we can go ahead and undertake our paired t-test. When we undertake hypothesis testing using the paired t-test statistic, the first thing we need to do is state our null hypothesis, also known as H0, and our hypothesis, known as H1. For the example we're using, our null hypothesis states there is no difference in employee sales before and after the customer service training course. Our hypothesis says there is a difference in employee sales before and after the customer training course. Once we've stated these, we can calculate our test statistic using our data in the matrix. And our test statistic is normally calculated using either SPSS or Excel or some other form of statistical software. In our case, our test statistic says that the t-test is 36.14 with 397 degrees of freedom. This means we have a large sample and a probability of less than 0.01. On this basis, the probability of our test statistic or one more extreme occurring by chance is less than 0.01, and this means we can reject the null hypothesis because this probability is less than 0.05. That means we can state there is a difference in employee sales before and after the customer service training course. We report our findings in our thesis, in our report or our dissertation by saying something along the lines of there is a significant difference in employee sales before and after the customer services training course, and then we quote our T statistic in brackets. We can go into more detail and provide more insights into this, perhaps by looking further at the data and our other analyses. So for example, we might say 6 months after the training course, employees' sales had increased from a mean of £30,543 per month to one of £38,234 per month. Selected reading which may be helpful to you as you learn to use the paired t-test comprises of Dances and Reedy's book, Statistics Without Maths or Psychology, and in particular Chapter 7. This is very useful on all forms of t-tests. Andy Field's book, Discovering Statistics Using SPSS. Chapter 10 here again looks at the t-test. Hayes' book, published in 1994, called Statistics, although published some time ago, is very good about the assumptions of the t-test and how these can be relaxed. Lumley et al.'s paper in Annual Review of Public Health, again, is really helpful on assumptions in data sets, and in particular assumptions related to the t-test. And finally, my own book with Phil and Adrian, Research Methods of Business Students, talks about the t-test in chapter 12. I hope you found this video presentation on the paired t-test helpful. Please do check out my other video presentations on my YouTube channel, Mark Saunders on Research Methods, and please do subscribe if you wish. Thank you.